You know, think back to 2016. Remember when Google Translate just suddenly got amazing? It honestly felt like some kind of magic. That one single jump was more progress than the entire decade before it, and it was all thanks to machine learning. And well, that's the kind of story that created the massive hype we're all swimming in today. But what does it really take to build systems like that? Okay, let's get into it. When most of us hear machine learning, our minds jump straight to, these super complex algorithms, these giant neural networks. But here's the real secret, and Chip Huyen just nails it with this quote. That stuff, that's just one little piece of a much, much bigger puzzle. The real work, the real magic, is in the system. So to really wrap our heads around how machine learning actually works out in the wild, we've got to zoom out. We have to look past the shiny algorithm and see the entire ecosystem that actually brings a model to life. Now take a look at this. This is what's so fascinating. See that little box in the middle? That's the ML algorithm we hear so much about. But look at everything surrounding it. You've got the user interface, how people actually use the thing. You have the entire data pipeline, which is this huge job of managing how information gets in and out. Then there's the infrastructure, all the behind-the-scenes plumbing, and of course the hardware it all runs on. Every single one of those pieces is absolutely critical. Without them, the best algorithm on the planet is, well, it's totally useless. So, this is the bottom line right here. Building a successful ML product isn't really a data science problem, it's a systems engineering problem. The goal isn't just to find the one perfect algorithm, it's to design, build, and maintain the entire robust system that it lives inside. All right, so now that we see the big picture of what an ML system really is, let's talk about the other big myth. This idea that machine learning is some kind of magic wand you can wave at any problem. It's really not. So let's get practical. Honestly, this might be the single most important question you can ask before you ever write a single line of code. And lucky for us, there's a really great framework we can use to figure this out. Okay, I know this looks like a dry textbook definition, but trust me, it's not. It's actually a super powerful checklist hidden in plain sight. For a problem to be a good candidate for ML, it has to check every single one of these boxes. Let's break this down. So number one, the system has to learn from data. It can't just be following rules someone programmed in. Two, it's got to be finding complex patterns, things that are way too messy for a human to just write out. Three, it needs existing data to learn from in the first place. Four, its whole purpose has to be making predictions. And five, this one's huge, those predictions have to work on new, unseen data it's never encountered before. Let's dig into that complex patterns idea for a second, because this is a really key distinction. I mean, when do you actually need this powerhouse learning system versus, something way, way simpler? And this slide just lays it out perfectly. On one hand, you want to find the state for a US zip code. That's a simple rule, right? You just use a lookup table. Easy, no ML required. But what about predicting an Airbnb's rental price? Well, that depends on dozens of things. Location, size, amenities, the season, reviews. The relationship between all those factors is incredibly complex. Now that is a perfect job for machine learning to figure out. And of course, this might sound obvious, but there has to actually be a pattern to learn from. You would never build an ML system to predict the next roll of a fair die because it's random, there's nothing there to learn. But you would use it to analyze stock prices because even though they're chaotic, there are underlying patterns in how markets behave that a model can latch onto. And machine learning becomes even more of a slam dunk when a few other things are true. Is the task super repetitive, like sorting millions of emails? That gives the model tons of examples to learn from. Is the problem massive, like at a huge scale where you need to make thousands of recommendations every second? And finally, are the patterns always shifting, like in fraud detection, where you need a system that can adapt on its own? If you're nodding yes, ML is probably a fantastic fit. So we know when to hit the gas, but knowing when to hit the brakes is just as important. And this isn't just about picking the right tool for the job, it's about not driving straight into a wall. Oh, absolutely. And knowing these red flags can save you an incredible amount of time, money, and heartache from building a system that was never going to work in the first place. Okay, here are the big 4 red flags. First, if a simple non-ML solution works just fine, please just use that. Simpler is always better. Second, you have to think about the stakes.
If one single wrong prediction, say in medical diagnostics or a self-driving car, could be catastrophic, you have to be unbelievably careful. Third, is the cost of building this whole system more than the benefit you'll get from it? If so, it's a bad investment. And finally, and this one is a project killer, if you don't have enough good, high-quality data to train on, your model has nothing to learn from. Game over.
So, let's bring this all home. What's the big idea here? It's really about a fundamental shift in how we approach machine learning. It's about putting on a new hat, the system designer's hat. And this is the absolute core of it. We have to move past just asking, hey, can we use an algorithm for this? The much better, much smarter question is, should we use ML here? And if we do, are we ready to build and maintain the entire system, the data pipelines, the interface, the infrastructure that it needs to actually succeed? So I'll just leave you with this final thought. Now that you have this framework, this lens of systems and checklists and red flags, which technologies that you use every single day look different to you now? From your photo app that finds your friends to your spam filter, you can now see beyond just the algorithm and really appreciate the whole, complex, and incredible system that's at work.